করবো? It's okay. So good morning, good afternoon থেকে. So I repeat, good afternoon. Welcome to lectures 57, 58 on thermodynamics of materials. First, you consider this one small error made in the caption, thumbnail caption of video 41, which is lectures 49, 50. Error is Thompson, the spelling. It should be Thompson. Okay, so this, please note this point. Next, let us consider, well, I tell you what, I will take up the assignment problems, or this is called actually practice problems. I have started already. We have started already. But before this, I actually want to highlight some salient points that we have already discussed, because to avoid any confusion, okay, this. Next, so let us consider the following points based on last day's class, okay. What is this? The criterion delta G is negative used for spontaneity of chemical reactions. Remember, it is not only applicable for constant pressure, constant temperature system, but also for any system like constant volume, constant temperature, isolated system, etc. So this is a great advantage, great relief. So only delta G is negative for spontaneity. But remember, this must be a chemical reaction system. For example, spontaneity, irreversibility, can I write? Then it will be irreversibility. Spontaneity mainly, okay, for chemical reactions. So, okay. For example, to illustrate, suppose an ideal 1 mole of an ideal gas, 1 mole of an ideal gas is compressed, is isothermally compressed. Isothermally and irreversibly compressed from state 1, which is P1 V1 T, to P2 V2 T. So what is the delta G? We know delta G is what? We know, it is easy, it is already known to us. dG is VdP minus SdT. As you know, this is out for constant temperature. So VdP or delta G is what? Integration of VdP, which is RT by P. This is already done number of times. State 1 to 2, which is RT P2 by P1. You know, is a compression, means P2 is greater than P1. Is positive. Since is compression, since P2 greater than P1. For I am very sorry. Thank you so much. Thank you so much. Yes. Please actually point out this type of errors. Thank you. RTL and P2 by P1. So this is positive. So what is this? For irreversible process, delta G is positive. What is this? Delta G is negative. But if you are alert, no problem. Alert means that this is not a chemical reaction system. This is for chemical reactions. This is a compression of gas. This is called fixed mass, fixed composition system. And this is a variable mass with or without variable composition system. You should not. This is actually, remember, this is here actually 2 variables fixed, then there is a change. But here 2 variable fixed means 3rd variable also fixed. So there is no process. So remember this. This is actually not why this is a fixed. This I discussed, fixed mass, fixed composition system. This is a chemical reaction system. Chemical reaction system, which is, that is a variable mass with or without with or without variable composition. This I told you number of times. Okay, so remember this. Okay, so what is the starting point here? See, for example, G is a function of what? So I explained you for this. How do you write this? Starting is what? G is a function of pressure, temperature, for example. Then here N1, N2, etc. And for this type of system, what you write? What here? G is a function of pressure and temperature, no N1, N2 variation. So in this case, even the pressure temperature constant, then you have change in free energy in the system. But here, if the two things constant, there is no change. So this is, remember this. Okay. So what I said that, but how to check? Then question. Then question arises. How to detect the irreversibility in this case? How to detect or detect the irreversibility in this case? So delta G positive, it should not work, because remember his origin is DGPT. So two thing constant system, there is no process with fixed mass decomposition. There is no process. Can you have two parameters fixed and there is any process with the ideal gas? Two parameter fixed. One parameter fixed possible, constant temperature, constant volume, or constant temperature, or constant volume, or constant pressure. But two things constant means third thing also constant, means no process. But this is possible. Two things still, why? Because of these factors, N1, N2, etc. You know these all things. That's why you get DGPT is negative. Although, so this is the main answer. But question still remains, sir, in this case, is there no hope of detecting irreversibility, ensuring? Yes, hope. Original hope is what? We take refuge in what? Take shelter in what? What is our last refuge? Second law of thermodynamics original. What is that? Delta's universe is positive. So, but in this case, what holds still? How to detect the irreversible in this case? Try delta S universe is positive. If everyone else fails, this will never fail. See, there is no constant on this. No constant, no chemical. Have a written chemical reaction? When you got the second law for anything on earth, or in irreversible process, positive, and reversible process, 0, and impossible process, negative. This is from these are all derived. This is the origin, parents of the other criterion, free energy, Gibbs free energy, Helmholtz free energy, other. So you know this I will not show how you can track. Remember this AC delta is RL and V2 by V1 delta is in. I don't want to show this. This is already shown. You can check back. Delta is universe when I said second law. There I showed you, demonstrated you. So this is the main problem. This is a one terrific problem. Sir, delta G compression irreversibility. You will say no. You cannot apply this condition. Okay, this condition after constant pressure, constant temperature, two parameter fixed. And third, okay, then still what is the change in free energy? Here, for example, here, even pressure temperature constant, system has a change in free energy. If two things constant here, there is no change in free energy because there is no process. So, but delta universe will not ever fail you. Will never, okay? Delta system. This was demonstrated. So, I am actually taking this first point or second point together. Another point is short, very short. Very short. I often write last day GI bar minus GI 0 is RT ln AI. Acha, already already shown. Already shown or already demonstrated, already shown before. You can check back. You have no difficulty at all. Isothermal process. This is so often used. I should give this as a name. There is a name to this. I forgot to mention that, although this is actually enough. This is known as GI bar M. This is known as GI bar M. What is the name? What is this? This is partial molar molar gives free energy or gives gives free energy of mixing please. This much I often I discussed, but this is sometimes written sometimes written as don't mind, written as delta GI bar M. A delta sign is given. Delta means change. Since it is a change, delta is a change. But I tell you, you don't have to. You may or may not use delta GI bar M. Drop delta. Why? Because
sometimes it is a bit hazy because the light is coming.
really sure that was my last year. It was.
That means there is a glare.
Huh?
There is a glare in the board. Reflection on that line.
আচ্ছা এইটার জন্য কি এটা পর্দাটার জন্য বাট লাস্ট do follow. Second point, once more I am actually explaining the name for this GI bar minus GI 0 is GI bar M. M for mixing. So it is partial molar gives free energy of mixing. Sometimes also written as delta GI bar N. But I tell you what, you don't have to write delta, you can drop delta. Delta for a change, so delta looks okay, but you may drop. What is the reason you may drop? Although change, M is a mixing means already change. M is a mix, M refers to mixing, means a change. So delta is a redundant. So that's why you may drop, and we often drop. But you may note this point. So with this, I have actually covered the pending points that I had to. Now I will take up the assignment problems. Okay. So let us move on to this. Okay. So last day we started problem 1. So it is actually, you give the heading. না ওটা আমি নিজে চাইছি না, এটা এতেই হয়ে যাইব। আচ্ছা, I'll try later. Sorry, no, I have already actually. This is actually a quick dry. You can use this. Okay, water. So yes. So now we'll take up. Next, take up. What is this? I say practice problems. Practice problems. One by one. Problem 1 already started. Last class. But for the purpose of continuity, I am again giving you the problem. What is the problem? Problem is what? Is what? Okay, thank you. Leave it here. Okay. Is it? What is this? Start with this. Find. Okay. Find if the metal. Find if the metal M. Okay, will be oxidized. Will be oxidized. This problem already have written. It will be oxidized to MO2 in a by an in an now this is practice problem that I started. Assignment not. After this over 11 practice problem, then I will take up assignment 7. Last class, but I have to continue because some corollaries were left. That time it was actually 140. I remember this. But so to maintain the continuity, So that's why corollaries actually I have to discuss. I remember this. In 1:1 oxygen argon. So I will go fast though. Mixture at 1000 Kelvin, okay, and PT 1 nanosphere. This is the problem. So what is the sketch? You must have a mental sketch or some physical sketch. You have a container we call crucible. You have a metal powder, metal solid powder, and passing here oxygen argon mixture. Oxygen plus argon in the 1:1 ratio. This open to atmosphere means open to atmosphere the exit. Atmosphere exit is this means 1 atmosphere system. It's a total thing. Quickly, so how do we know our criterion of this? So solution. Okay. Achha, delta given actually. Achha, I am writing given delta G0 is what minus 60,000 plus 50T. This form it will be obtained plus 52 joule. Quickly, now you try to find out what Q and K. From this, find out K. Delta G0 is what? Minus RT ln K quickly is minus 8.314. T is the temperature of what? Oh, right here. 1000 K is maintained here by thermal control. Okay, what is temperature controller? RT 1000 ln K. Okay, or you get K as how much? It's 3.3, I believe. 3.33. 3.33. Leave it there. K is there. K, actually, you always assign the temperature here. Here also, here also. You put this value. Okay, here. So K is, you can write here actually. Achha, delta G0 1000 is what? How much? Yeah, put this here minus 10,000. 10,000 joule is RTL and K, okay? This is minus RTL and K. So from this, okay? This is K1000 also. So this part is done. Now what is the Q? Question is Q. This is the K. Important K. Q is what? Right? Is the activity of the reaction under study. Otherwise you cannot the reaction under study. You must write this well. M solid plus O2 gas goes to no arrow equal sign. MO2 solid. Happy though? Okay. This delta G0 is there and this is delta G is given. Okay. Good. So Q is what? Right? Activity of the product, activity of the reactants, O2, this is actual. Quickly, so this is how much? One thing you have to note here, activity, what is present here? M solid present, so pure substance activity is 1, I said. Activity of gas is what I said? Activity gas, partial pressure itself. PO2 by activity has no unit, remember, but PO2 by 1 is PO2, which is how much? Which is how much? What is the PO2? Actual 1:1 and total is 1. So say 0.5 atmosphere. Good boy. MO2 actually MO2 is not present, but there is no difference between MO2 being present or absent. Okay, because you have to write this here. MO2 I am writing here 1. MO2 is 1 because note this you have to because MO2 will be produced, although present or absent does not matter. So this is the reason MO2 will be produced pure, will be because you will produce pure when you are pure. How can it be impure, sir? Is there any possibility of its being impure? Yes, possibility is there. Suppose you may keep some silica, SiO2. So this MO2 and SiO2 will make a slag by alloy. So that time MO2 will be impure and it will not be produced pure. At that time we cannot put the value of 1. It will be less than 1. Then it is difficult. Okay. So but when it is pure, okay. So in absence of any other substance present in the reaction system, So MO2 will be produced pure. Okay, like say FeO, calcium oxide, silica. Silica, silica is a producing pure. But if calcium oxide is already present, then CaO SiO2 to form a slag. Slag means solution, means activity is less than 1. So it cannot. But what value you don't know, that is a difficulty. That is more involved. But for the timing, we have no such difficulty. This is the one great lesson. You remember this, I will use often. It will produce pure. Okay. So what is this value? 2. 2. What is then? Then thus Q is less than, hence Q less than K. Achha. So Q less than K. Q is how much? Right? 2 against. So your comment is, so comment inference, the reaction is spontaneous. The reaction will occur. The reaction oxidation, the oxidation of metal will occur. Spontaneous. So this you understand. Okay. Another alternative is quickly Q less than K. You original is what? Delta G is negative. Alternatively, tell me delta G is negative. Delta G is negative. Try delta G is negative. How? What is the delta G, sir? Remember, I am talking of the same thing. You appreciate this, then you will full comment. What is this? Delta G is delta G0 plus RT ln Q. Actually, I tell you, delta G, I will work with this, but I am showing you why Q less than K, same thing. Is what? Minus RT ln K plus RT ln Q, or simply is RT ln Q by K. So you clearly see when Q less than K means delta G is negative. Same thing. Okay. So, but you try for your satisfaction once, since it is the preliminary problem, basic, simple problem, okay, okay, rudimentary problem. So, so what? So delta G, sir, I try delta G. Delta G0. What is the delta G? Substitute this. So try this part. Try this. This first line. Delta G is minus, right nicely, minus 60,000 plus 50T plus RTLN, right first, Q. Now Q, you know, Q already value you have found, the same way you find, the quick substitute. It is actually T is how much? T is how much? Please tell me. 1,000. And this part you know how much? Minus 10,000. 10,000 plus it is 8.314 like before. T is 1,000. ln2. If you do this value comes as, since I have the calculations, 5763, good boy. This is 5763. This is 5763, and you have no doubt it is negative. So you are fully satisfied that either delta G is negative or Q less than K. Since delta G is negative is so commonly used, common phrase, delta G is negative. Oh, but all the same. Okay, now the corollaries. This is actually, I am now at par with last day's class. Okay, now corollary. Now this is actually challenging for you. If I actually ask you these things, let us have this. Let us see. Actually, I am still not. Which point I'm removing all this. I'm removing all this. All is over. Corollaries. Now you see. First corollary is corollary 1. Number of corollaries coming, you try to follow me. Corollaries 1. Corollary 1. What is this? Let me check actually which one I will discuss first. This is a good idea. At what temperature the metal, the metal M will not be oxidized? Will not be oxidized. Why I am asking this? Not be oxidized. Same, other is same. The other is same condition. Under otherwise same condition. Under otherwise same conditions. You understand this? Same conditions. Means what? I am passing 1:1. Total pressure 1 atmosphere open to temperature, sir. At what temperature? Now, why I ask this question? This is some actually usefulness, importance to metallurgists, because metallurgists will not like to have metal oxidized. They actually produce metal, extract metal. So not for destruction. This is actually corrosion and oxidation. So you want to stop this. So you may want us under the giving condition, is there any other temperature? This temperature we have found it will be oxidized. Any other temperature? This type of problem when you come across, you do this. I tell you, you consider let answer. At what temperature? Let T be the temperature. First time, let T be the temperature. Then you see, you said this. I'm telling you, delta G is 0, you try to find out. Interesting. Try to delta G is 0 at what temperature? Then you will have to do whatever you have to do. 0 is delta G 0. It is minus. Tell me delta G 0 plus again RTL and right. Just actually in a flurry you say delta G 0 plus RTL and Q. Delta G 0 is again minus 60,000. Write this 50T. Your bracket perhaps RT 8.314 T ln Q, same gas, otherwise same. So you do have no doubt ln2, good boy. Acha. So what is this? In Nirjal will tell us T. How much T? What is the 1000 Kelvin or unknown? Sir, don't ask this. Sir, this is if T is known, left hand side, what are you doing, sir? Here. Left hand side. So what you must have a problem to solve. So unknown T is unknown. I'm not showing this. Shall I show this? You do this yourself, unnecessary talk. T is, this is so easy. Temperature, I know the answer actually 1076. Okay. Take a look. 1076 K. Very good. Very good. So what is the answer? Your answer will be, so at any temperature T greater than, you don't want delta G is 0. You want what? To stop a reaction, impossibility. You like impossibility now. To delta G is positive. To make it positive, if this value of T makes 0, then any greater value of T will make it positive. So any temperature T greater than 1076 T will be any answer. Answer. Metal, I'm not writing. Metal will not be oxidized. You follow this point always. You follow this. About delta G. Is it 0? Delta G. This is 0. This side is positive and this side is negative. This domain is what? Tell me, this is spontaneous domain. This is what domain? Impossibility domain. And this is equilibrium. This point is equilibrium. Right. So first, since this is the range, what value of delta G consider? No, sir, cutoff value is important. Critical junction, sir. See, this junction is 0. Let us find out based on this temperature, then make it positive. How? Any temperature greater than, okay, this part is over. Second corollary will be what? Let the temperature. See, the second point is, acha, good boy. At PO2 is 0.3 atmosphere. What will happen? Will the oxidation will occur? Will the oxidation occur? Achha, let us not, will the oxidation occur? Question, actually another question, random. 0.3, how will you get 0.3? Tell me. That means, if you want a mixture, 0.3 normally we want actually 1 atmosphere for flow, 1 atmosphere. 0.3 vacuum type, less than 1. So it is better mix with argon so that it is 1 atmosphere, but oxygen contribution is 0.3, means it is 3 is to 10 oxygen is to argon. Obviously. Okay, no. 3 by 13. 3 by oxygen is what? 0.3, 0.7. 3 by 10, no? No, no, what is also what is the 3 is to 7 7. So I'm very sorry. 3 to 7 oxygen is to argon. I'm very sorry. Thank you. You are actually following this very well. 3 to 7. So if I make any mistake, 3 to, instead of 1 is to 1, 3 to 7, then what will happen? So what will be the answer? I'm giving quickly. I'm telling you. What is the key? What's the key for this? Tell me. Achha, answer. You quickly. You can answer yourself. Tell me. Is it actual? Actual. It is follow. One is actual and equilibrium constant. I I wrote previously is the equilibrium value. Okay. Same. Otherwise same. Activity ratios. As Q is what? What is the Q value is what? 1 by 0.3 means 3.33. Now what is the K? Versus K is what? How K is what? Oh, this is a good question. 1 is to 1, 3 is to 3.33. 3.33. This is a good question also. 3.33. It's okay, it's okay. So what will you comment? Let it be so. What will you comment?
Already, already.
So that means the equilibrium composition you are sending. So no, this refers to delta G is what? The Q is K. So that is Q is K. Q is K or delta G is 0, whichever you like. So this is equilibrium condition. What will you answer? What will you answer? Like all the same? Then no oxidation will occur. Equilibrium condition also no oxidation. What is the difference between equilibrium? Means neither way reaction will occur. And what is positive? When equilibrium is reaction will not occur, positive delta G is positive, reaction will not occur. But the reverse direction will be negative. So this is the difference between equilibrium and delta G is positive. Delta G is 0 and delta G is positive. So this is okay. So equilibrium condition, so no oxidation either. So no oxidation. So no oxidation of M. Third is what? If it is 0.5 atmosphere, shall I try? What I tried again? 0.5, 0.3, up to 0.7%. No? 0.1. I'm very sorry. 0.1 atmosphere. Yes. 0.1 atmosphere. If I change this, 0.1 atmosphere. On oxygen is how much? Tell me. Then what will occur? Okay, repeat this. Okay. Second. Now this is third actually. No, this is third. What is this? How much it is? 10. Okay. So actually repeat this. Repeat this. This third. Will oxidation. Q is 1. So third is this. Then what is Q is what? 1 by PO2. Actual write here. Always write this. Tag this actual is 10 is greater than 3.33, which is K. So Q greater than K means delta G is also means delta J is positive reaction impossible, which you good boy. You're right though. Now tell me, how did you achieve this? This is also reaction is impossible. A moment ago, you got reaction impossible. What is the difference between this approach and that approach? See, corollary what? Corollary 1. You get reaction impossible now? Your answer was T greater than 1076 Kelvin. Here also you say, no, it is impossible. So what is the difference? Here, there your approach is temperature. Without changing the composition, yet without changing the temperature, composition what issue? So this is actually, I tell you, it is actually equilibrium less than equilibrium. You get more actually okay light on this over. So fourth corollary is what? Last corollary rather. Fourth, it is interesting. That's why I am taking up. Okay. Again, at what temperature metal won't be oxidized? Metal won't be oxidized by 1 atmosphere oxygen. Sorry, by 1 atmosphere oxygen. At what temperature I'm talking of? At what? I'm very sorry. Okay. 1 atmosphere, and at 1 atmosphere pressure, at 1 atmosphere pressure already open to atmosphere, to at 1 atmosphere total pressure. This is redundant. It understood same problem. So what have done? This oxygen alone is moving. No argon, oxygen. So again you try the same procedure. Let T be the temperature. Let answer. Let T be the required temperature. Okay. Then how will we proceed? Remember, very interesting. There is something new. That's why I always take up every problem. I am actually considering which have new features. I try to actually master this and comment fully. So again new. You get something new is coming. Let T be the temperature. So what will you write? Right? Zero is again cut off delta G is zero. Zero is delta G is delta G zero plus RT ln Q. Delta G0 RT ln Q is what? 1 by PO2. Right, once more. Oh, actually, I'm sorry. I'm very sorry. Actual, this is what? 1 by 1 is 1. So it is, whole thing is 0. So delta 0 itself. So this is a situation when delta G is equal to delta G0. Delta G, what is this value? Achha, this is, tell me, tell me, minus 60. Write this plus 50t. 50t. You solve, T comes out as T as 1200 Kelvin. So what is your answer? Sir, T. No, you can write this way. I wrote the other one thing I wrote, but it is better answer. You write. So answer T any temperature, sir. Equal. Input 1200 also. That is equilibrium. No reaction. So any 1200. This is your answer. But one thing new, sir. What is new, sir? You said, sir, new. This already you solved. This is a special case that when delta G is delta G0, what is your criterion? Tell me, what is your criterion? Delta G is 0 for equilibrium. Means you wanted to find the equilibrium. But in this case, delta G0 is 0 also the criterion. Serve as the criterion. Why, sir? Because delta G is delta G0. Original is delta G0, never forget. If you still ask me, sir, even more original, second law, original, second law. Delta's universe is 0. That always. Don't be actually, no, okay, this, swamped away by this, okay, carried away by this, but we will use this for, because this applicable for system. Delta G is 0. But this, under what condition? Q is 1. So, reactants and products are at, under unit activity, means standard state. Actual reactants, products, standard, follow, here, see here. Standard, M standard, pure, oxygen is going 1 atmosphere. What is the standard state for gas? 1 atmosphere. And MO2 will be produced pure, standard. So reactants and products are standard, means that this term will drop. And delta G becomes equal to delta G0, means anyone will serve as the criterion, because they are equal now. So delta G0 will also serve, and because delta G0 is given to you. So use delta G0 freely to find out the temperature and then the limit. Okay, good. So here, since, right, comment, since reactants are products, let me write, okay, this one, since reactants and products all uh, all are at standard states, drugs are all at standard state. Q is, right, nicely, Q is 1. Activity is 1, Q is 1. So that leads to what? Tell me. Delta G is delta G0. So can I start this? One point I should write here. So all over. So this is all over. This problem is over. Problem 1 is, so let me write. So under this type of condition, under this special case, delta G0, which is equal to delta G, equal to delta G will serve as the criterion of, tell me, spontaneity, equilibrium, impossibility, or impossibility as tell me, why, as tell me, sorry, delta G0 is less than equal to 0, less than equal to 0, or greater than 0, it is less than is spontaneous, spontaneous is equilibrium and impossible. You understand this? So this is a special case, special case. But we should be alert. We must be prepared for everything. It's okay. You have any problem? Okay, it's okay. So can I remove this? Problem one is over completely. So if we actually we have start. Problem 2 starts with this. Problem nicely right. Now let us take up practice problem. Problem 2, practice problem. Let us write down the problem very well. Okay, that is consider the reduction of, quickly let us move. Consider the reduction of FeO solid, means they call it Oostite. Oostite we say technically, metallurgically Oostite, by CO2 mixture. By CO2 mixture, which is very common in blast furnace stack. CO2 mixture at to Fe solid, you can write in bracket, at element 73 Kelvin and P atmosphere. I have given not 1 atmosphere, at P atmosphere. P atmosphere, okay. What is the question is, find the effect of the inlet CO by CO2 mixture, inlet CO by CO2 mixture on the reaction feasibility, okay? On the reduction, on the feasibility of the reaction, on the feasibility of the reduction, on the reduction feasibility, on the reduction feasibility. This is a question. Solution. I'm writing the reaction under study. First you write, otherwise you have no clue. The reaction under study. The reaction under study is what? Write nicely. FeO solid reacting with CO gas, forming Fe solid plus CO2 gas. This delta G0 is available. It's available. Okay, it's given. I'm not writing the data, but giving. Okay. So now actually what you try to do this year, I tell you. Now you do, okay, find out delta G0 at temperature, what temperature? 1173, since it is formed in the A plus BT type, okay, A plus BT type. A plus BT, A is the, okay, A plus BT, A is given, A is known, A is given, A known, B known. So hence delta G0 is known as function of temperature is not, is A plus BT. So 1173 you will get this value. I'm not finding, giving you the data. That leads to what? What? Using K 1173. How? Because delta G0 is minus, I tell you every day 100 times. This number one relation in chemical thermodynamics, minus RTLNK. This is so easy to you. This value, if you calculate, this will be actually 0.45. 0.45. This can be shown. This you will get data later. 0.45. This can be shown to 0.45. Okay, very good, sir. Now what is K? What is this? Or What is K? Tell me. Write nicely. What is equilibrium? Write. A activity K is start. What is the K, sir? K 1173 can write. What is this? Activity. Tell me. Product by reactant. Fe. Activity CO2. Tell me. Activity of FeO. Remember Q and K same value, same term. Numerator, denominator. Only one is equilibrium, another is actual. But what shall I? What? Since you are beginner, always actually, so that you have the ambiguity. What is this? Equilibrium. Equilibrium constant refers to equilibrium. At equilibrium, this. Now, what is the value? Tell me. This reactions. What is the equilibrium? FeO. Oh, you want to have a sketch again? Similar sketch. FeO powder you have taken. FeO solid you have taken. You are passing a CO2 mixture. You know, CO2 mixture in blast furnace stack also CO2 mixture. You know, 2 years it is pure CO, but gradually it becomes enriched with CO2 mixture, and it is on the stack FeO. This reaction is the predominant reaction. CO2. Okay, what is the temperature? Always mention temperature. 1173 K. Okay, temperature is very important, and is open to atmosphere, so total pressure is 1 or P here I have said P. So this okay. Now tell me under this, so it will produce this reaction at an equilibrium. So I am trying to get hold of the equilibrium value. Then I have a control on the reaction. The equilibrium will give you actually good reference. Then you will actually make it either Q greater than K or less than K depending upon your requirement. You want the reaction occur, so I will make Q less than K. I don't want the reaction. I will make Q greater than K. So K is the reference. Why? K and K is available easily from delta G0. The data A plus B that will be given, and a minus, simply minus RT ln K. Okay. Good boy. So what is the activity of FeO? Tell me. See here. See at equilibrium, when reaction is equilibrium, okay, FeO. So this will be present actually, and the iron will be produced. Pure activity is nothing but partial pressure, as you know. Okay, so PCO, what is this value? I have already given you. If you do the calculation, what is this value? 0.45. So you will get 0.45 is, I am writing for you, PCO2 by PCO. Here I am giving you is NCO2 by NCO. I am showing you how. If you follow this, I will not repeat. PCO2 by PCO2. PCO2 is what? Tell me. Partial pressure is what? You know very well. Tell me. XCO2 times total pressure. First thing you know, partial pressure and total pressure. P is the total pressure by XCO times total pressure. This is P is the total pressure, right? Right? P is the total pressure. P is to, I tell you one thing. Sometimes books or me or you sometimes written as P or P total, PT. Will be difficult for you to follow. You don't care. Don't say whatever symbol you have bringing. Okay. Symbol will not actually perplex us. Okay, so good boy. So XC2. What is this? See, why the total pressure has no effect? Cancel out. So any pressure, damn 1 or P or 0.3. So XCO2, what is this in terms? I'm going in terms of moles. So what is this? XCO2 is what? Tell me. NCO2 by NCO. Will you mind this? Let us Sukul, I will test you. XCO2 by XCO is NCO2 by NCO. Do you mind? Why not mind? I mind. Why?
Number of moles of CO2 by number of moles of CO2 plus CO.
Good boy. NCO2 by N total. By N total both sides, numerator, denominator, then becomes XCO2. And now N total and cancel. Good boy, very good. I am very happy. Yes, this is the courage you have to have. Okay, NCO2 answer. What shall I write here? Tell me. One thing I missed. Tell me. Very important, because equilibrium, sir. Your beginners always insist equilibrium or actual. So at the end, at least you write equilibrium. So what is if NCO2 by NCO is 0.45? What does it mean? Percentage CO2 is how much? Percentage CO2 is what? Can you tell me? Percentage is what? Actually, from this you will get XO2 by XO. So anyway, you do this. Is what? 1.45. 45. How much it is? You know, percentage CO2 is how much? 0.45 by 1.45 is what? 67. Can you try this? And I'm very sorry. 67 and opposite of 67 is 69, 31. Please check this. Percentage is 31%. Just check whether it is 0.31, whether it is 0.31. 0.31 is sure it will be. It will be sure. You can have to check. Do you have? It just divide 0.31 per is into 100, into 100, into 100. 0.45 by 1.45, 31%, no doubt. And what is 31%? Okay. And what is the percentage CO2 then? Tell me. Yes, CO. CO is, tell me. I've got this value, 31
Yes, yes.
is 69%.
100 minus 31.
100 minus 31. Okay, 16. Very good. So what, this is the equilibrium, right? At equilibrium, right here. Again, if we have not written at equilibrium. Now tell me, effect of the inlet CO2 mixture of reaction feasibility. So what will be the answer? Sir, so you write. So any uh, any gas composition, I will clarify this, with percentage CO greater than 69% will be reducing, it will spontaneous. I'll explain this. Will be reducing with respect to APO. This is your comment. Over. Or anything below, non-reducing. Okay. And exactly this, so it will be a, okay. See, but I tell you what, I clarify something here that will help you. Just this part you don't need, you have written the problem, you follow one by one, 3 cases. Further, stop, see that. What happens? What happens? Maybe this is running out. Okay. Acha. To illustrate, illustrate this quickly. 3 cases. 3 cases. One I'm giving you one by one. You answer quickly. Just quickly. Let us 75% CO, 75% CO, and 25% CO2. Tell me. You quickly will answer this. See what is the reaction I have actually removed. Unfortunately, I should not remove the reaction. Reaction should be plus CO gas. AP solid, sorry, CO2 gas. Okay, ठीक है. 10% CO. You see, anything greater than 60, this will be reducing. But you should be actually systematically also, methodically also. Q less than K, Q greater than K, delta G positive. So bring that way, sir. This is okay. Common sense. Common sense. I tell you what. अच्छा, I tell you what. अच्छा, ठीक है. अच्छा, Q is what? Please, Q is what? Tell me, please. Q is what? How much? Q is, see here, Q is what? You see, this is K. So Q is exactly similar. Activities are all out. Same way. PCO actual, right? Write this. Actual. What is, these are the actuals that is being paid. Actual. What is the PCO2? Please tell me, as you know that way. 0.25 or 25 or 0.75 is what? 1/3 is 0.33, and K is how much? Already you have found. Tell me. 0.45. So Q less than K. So means, so reaction spontaneous. Reduction is a reduction here. So reduction, when you write, then you write more. Reaction is generic name. Reduction is spontaneous. Reduction is spontaneous. Means reaction will occur. Or reaction will occur. So spontaneous, okay, sir. Happy to. Good boy. No any problem here. And means delta G is negative. Another way I'm telling you, I'm giving you this Q less than K. Okay. So Q less than K or 1 by Q greater than 1 by K. Will it be difficult? Or 1 by Q. Why I'm saying this? Greater than 1 by, I also use this sometimes. What is this? For spontaneity. For spontaneity. Note. Q less than K means less than K or 1 by Q for spontaneity. So why see what I'm trying to tell you, follow this way. If C, 1 by Q is what? 1 by Q is what? Here, 1 by Q. So remove this figure. 1 by Q, yes, please tell me quickly. Q is what? Q, first of Q is CO by CO2. So CO by CO2. CO by CO2, percentage CO by percentage CO2. And K is what? It is actual, or CO, people sometimes like CO by CO2, means percentage, partial, pressure, mole fraction, moles. Okay, and what is this? Percentage CO by percentage CO2 equilibrium. What is the requirement for spontaneity? This is 1 by Q is this, so it must be greater. So I tell you what is the reaction I wrote here? So CO actual, forget. If numerator is taken care of, denominator is automatically taken care of. If nothing is dependently, okay, dependently governed. Okay, because you know one, concept on one. CO increases. CO is greater than the equilibrium. Equilibrium value is what? How much you calculated? How much? CO? 69%. So say, see, common sense. So equilibrium is balanced state. So they're balanced. Delta G is 0 means P and G is same. So you want to make it occur. Make it occur. So what you try to do? Make a push. I'm explaining number of ways. First is you make a push. So equilibrium is what? Requirement is what? 69 CO. Constant on CO, automatically CO2 will be taken care of. 69, anything above CO, then it will be pushed to this. Yet disrupting equilibrium situation by making it greater than equilibrium value, greater than 69%, so 75%. What is this? 69%. What is the CO agent? Okay, 75%. So anything 69%, 30% balance. Up, it is greater, reaction is follow. Push from this side, this disturbance. So equilibrium is disturbed. So and then it will respond how? It will be removed. It tries to come back to the equilibrium value. So it will be consumed CO. Okay, CO is not so much, 75, no. So how to consume? Now, by moving in the forward direction and CO2 up. It is down, up, then back, trying to come back to the equilibrium value of 69, 31 combination. So reaction will be this direction. Okay. Now you try, but you also continuously disrupt the equilibrium, continuously pass, continuously, and continuously spontaneous until AQ is fully reduced to iron. Maybe your desired thing. This one. Another I tell you. Another thing I tell you. So delta G. Additional statement was here. G of this. Actually this place. Okay. Achha, I'll explain this. Achha, I'm telling you. How a reaction can occur, make a reaction occur? How? By making it delta G is negative. Delta G is negative means, tell me, G of product minus G of, by making G of product less than G of reactant. Very good, very good. If you have catched this point, very good. G of product is less than G of reactant. Equilibrium is a good reference always. If anyone has a good comment on equilibrium, here you solve all problems. Equilibrium of delta is 0. So shall I? Delta is 0. Equilibrium what is what? So I think you have got this answer. So I will not discuss remaining part. I leave this here. Achha, maybe this it is actually running out. So I try another one. Maybe this or otherwise I try. Start. Follow this part. Reactant, product. So free energy GR, GP, they are equal. This means delta G is GP minus, they are equal. So this is G, okay, this direction G. This is the G direction. So here GP, GR, GP. So delta G is 0 means delta G is what? Tell me, GP minus GR. Reaction is what? Reaction is what? P to R. R to P. R to reactant to product. Reactant to product. I'm very sorry. Reactant to product. So what is delta G? GP minus GR. Now tell me, when delta G is, you try to do what? Delta G negative. What you try? Tell me, you want to to make delta G negative, you have to you try Gp negative, Gp decreases, Gr increases. So it is level say I'm trying one effort I'm giving you. GBR is make it negative, product minus reactant, not reactant minus product. So you try to increase this or decrease this or both. Try this, increase and try to decrease. Then it is delta G is what? Product minus reactant. Now see, this is here, this is the G scale negative. So this is actually Gp minus, this is Gp minus Gr. If you try opposite, opposite is what? So you write here Gp minus Gr is right. This is Gp minus Gr is negative. Negative. And you write here another figure I draw R2P. Happy? Now you say this, say here G scale. You do opposite. You are doing what? Decreasing this. Sorry. You decreasing this. You are increasing this. Then Gp minus Gr is actually Gp minus Gr is positive. This is actually this is G scale. Gp minus Gr is positive. Reaction impossible. So now what is the lesson from this? This is easy to say. Gp minus Gr, all right, delta Gp minus Gr. So Gp minus Gr is, yeah, right, delta Gp minus Gr is negative. So Gp minus Gr is negative, reaction spontaneous. Now learn this. Although I'll discuss this later on also. Spontaneous. Okay, sorry, this will not work with hand. Okay, spontaneous, and what you write here? Reaction impossible. Okay, and when they are same, okay, so what will be your aim to make the reaction occur? Increase the reactant free energy anyhow, or decrease the product free energy. What are the measures, sir? Yes, it's okay, very good thing, sir. So anytime you see there is a difficulty in the reaction is not occurring, and your teacher is asking, see how to do this, how to make it feasible. You are thermodynamicist, so you try actually giving the temperature. The temperature itself is a measure. Giving the temperature, you try to reduce the activity of the free energy of the product and increase the reactant. You might say increase free energy means related to activity. Gi bar is Gi 0, RTL and Ai. So try to decrease the activity of the product, and this is the lesson forever. So anyhow, I will try to decrease the activity of product, and if it is impossible currently, not impossible, and impossible can be made possible. Thermodynamics teaches us. Thermodynamics actually predicts the impossibility, concludes that this reaction is impossible. Then it actually at the same breath says, oh, do this, then it will be possible. Always this has happened. Heat flows from high temperature to low temperature, never from low to high. Low to high, impossible. Then he give a clause there, qualifier. In an isolated system, impossible. If you want to make less, then say it is possible, low temperature to high temperature. So next moment, if you do this, some work done on the system and break the isolation. So this is all about second law. Here also, so it is impossible is found, then you try to reduce the activity. Free energy means free energy related to Gi. Always, yeah, I may write here Gi bar minus is Gi 0 or TLNS. So you know they are hooked up. Good relation. So you say lower, reduce the activity of pressure, product. What is the measure? What is the activity, sir? If it is a gas, any gas species, what is the activity? Partial pressure. So you produce at a lower pressure, then perhaps it is vacuum maybe. This is the measure. Or maybe another, how to lower the activity, I tell you. A moment ago I said, say you are producing the product at a standard state, pure state. Make it impure. So give some solvent from the beginning, so that the moment it is produced, it will be impure, so activity will be lower, and reaction will be more. Reaction will be like this, huh? Reaction will be. activity, final activity. Free energy, original free energy activity will be sir lower. So this is this. How to increase the left hand side? So it is already pure. What you will do? Increase the activity, but it is all left hand side. Sir, one, sir, one is the maximum. Nothing doing. Nothing doing. Another is maybe if the gas spaces, possible. Increase the pressure. This you understood though? Okay, very good. And if you don't decrease, okay, don't make the solution left hand side, then in fact it is actually you are ruining your prospect. Okay, and then you understood this point though. Then another point I am saying, these are the measures for a given temperature. Then temperature itself is a measure. Next, temperature can change the, okay, delta G is negative, but you can actually change, you have seen delta G is positive, and you change the temperature. What temperature? Any temperature greater than 10 system. This is another measure. Later on you will study because temperature changes the equilibrium constant. So later on, but if you jot down these 2 points, I cannot write so many things. But I tell you, this will guide you throughout your course, through your life, that how to make a reaction, and impossible reactions is possible. This is okay. So follow that, so that delta G is negative, and then free energy theoretically or activity wise. Good boy. So this is okay. And about the temperature, etc., I will discuss this. So this problem I will not discuss further, because I have already covered 2 points. You can answer all these things. So you are following problem 3. Problem 3 is a very classical problem, but I will actually touch upon this problem 3 quickly. Problem 3. So right, this is a simple problem, I would say, but still I will cover for the purpose of coverage. Okay, consider the gas phase reaction. Consider the little quickly. Simple problem. What is the gas phase reaction? CO gas plus 3H2 gas, CH4 gas plus H2O gas. The gas phase reaction. So what is the question? So consider gas phase reaction. I tell you what. This is the question. This is the question. I tell you what. This is a problem. The problem is giving this. Problem is this. I'm giving in the form of sketch. You have taken the honest truth is I'm following stoichiometry, but normally I violate stoichiometry. But in this case, I'm following. So 70% hydrogen and 25% CO mixture I am inletting, admitting into a reactor. Reactor is a flow reactor. What is the temperature running? Temperature running is tell me what is the temperature T. I'm not giving data, so write some temperature. Okay, you have to. This is the inlet, and this is actually gas is exit gas. Composition is what? This is the question. Open to atmosphere, right? Open to atmosphere means you know very well what is the meaning of that. Open to atmosphere means P total is 1, and T temperature will be given. So the gas is actually gas is flowing like this. Sorry. Exit gas component, and you have to consider that gas is actually while living, it is in equilibrium state. It is a flow reactor sketch. Flow reactor sketch. Opposite I am telling you, say I am showing you. Actually I tell you what, the closed system analog is a closed system version. Closed system version is what? It's open system. Flow reactor means open system. What is the closed system version? Closed system version is what? Like this, you know very well, closed system all along cylinder piston. So sir, pressure 1 atmosphere, this is 1. I am applying, sir. There is a thermostat, sir. Temperature, sir. This temperature may be 900 degree Kelvin. And what is there? You are taking CO is to hydrogen, 1 is to 3. That you have taken. Careful about this. CO is to hydrogen, 1 is to 3. This is the initial state. Initial or non-equilibrium state. Understand this. That's why reaction will occur. This moves to the equilibrium state. Okay, here you leave it, allow time, and so what will be this? This side you draw this. P is 1 atmosphere again. Since this is constant pressure, constant temperature. T. Then what is happening here? What will be present? Which gases will be present? Tell me. Sir, product gas, unreacted, and at equilibrium means it will be stopped somewhere in the middle. This is normal constant. Equilibrium, some in the middle, sir. Some conversion, some unreacted. So it is what? CH4, H2O, CO, hydrogen, all. So you write, find and the composition. To find the equilibrium composition, in terms of percentage. In terms of percentage, okay, mole percent. This percentage, why I say, remember, it is mole percent. Mole percent, not volume percent. Mole percent. It's very safe, very safe. Volume is very treacherous. Volume is dependent. Gas volume is depends on pressure, temperature. Okay, but mole, no problem. This is the problem. Either this or that. Here also say this is this. This is this. Going through. Interesting. This is actually what is the difference? Main difference, which is more difficult to achieve. Equilibrium. Oh, right. Final. Excuse me. And this is right. Equilibrium state 1, state 2. Okay, equilibrium state. What is the difference between these? Which is easy? Which is easy to achieve? Equilibrium you want to achieve, because you can use equilibrium constant. Equilibrium constant requires equilibrium values. The equilibrium value you can find out. So if you know equilibrium value, and okay, you find, okay, and then if it is not equilibrium, that also you give some idea that it is below that value, like this. Okay. So consider equilibrium. In which case it is easy? Answer is, so this case. Because this is a running, moving, gases moving along, and it may not enough time to attain equilibrium. Equilibrium means a reaction. A time will come when it will be equilibrium. But how much time here in a flow reactor time? So it's fast moving, typically. And here a closed door, nothing escapes. So you have enough time. You have actually charged it and you have left this place. And after 1 hour, 2 hours, you come back. Then it has already attained equilibrium. And you know how to detect equilibrium. You see, if you take out gas sample and see the composition with time, you say, oh, same, means equilibrium has achieved. So here you have to consider, even though this is a flow reactor, which is very commonly used and very useful, because it is actually flow reactor means you actually write is open system. Then you actually what? You assume, you consider that this reaction when it exits, before it exits, it attains equilibrium. This is the consideration for all problems that I will consider. If it is, or other way mention that it has not attained equilibrium. Otherwise, it has attained equilibrium. So exit is, it is attained equilibrium. So like this state, it has attained. Okay? Reaction. Then so fast. Then what is the argument behind it, or what is the defense? Now it is so fast that it has attained equilibrium. Kinetics is fast. Kinetics so fast that it will attain equilibrium. And typically metallurgists consider high temperature. And high temperature chemical reaction kinetics is fast. If it is fast, then actually what happens? So it is not actually bad assumption, bad consideration, that okay, unfair consideration that it is lacking equilibrium. All these things. Give all these things okay over, then solve the problem. Let us consider solve the problem. Okay, again you write what is this is okay. So solution. Let us consider n moles. Let n moles of CO. I'm writing n moles of CO and 1:3. 3 times as much moles of hydrogen charged. So what is this? Write this way. Follow this. So you can write CO gas. Sorry. Go slowly. 1:3 moles. So 1:3. It is written 1:3. 75. 1:3. Right. CO is to hydrogen. CO is to hydrogen. Inlet. 1:3. 75%. Okay. So charge. So you write this way. This is a special method to solve this. Okay. This is what I'm very sorry. Typical method to solve this is what? CH4. Write once more. Write. Quickly write. N more initial. This way. This is the technique. Initially. What you have charged? N moles. How much? 3 N moles. What here? And what here? I have not charged any. I could have charged. If I have to say this 2 N, possible. So, but you consider, since it is a simpler problem, 0. At equilibrium, what happens? Alpha moles have reacted. Okay, so n minus alpha, and if alpha for CO means there are 3 alpha for hydrogen, so 3 times as much, 3n minus 3 alpha, and 1 against alpha. So what is n total? I write in the gas is what? How many is it? 4n minus 2 alpha. But see, 4n minus 4 alpha minus 2 alpha. This will be required. I'm moving fast. Delta G0 given, right? Given. This part I'm not writing. Don't waste time. Because this is a plus BT. Given means delta G is given. So what you will find out from this quickly? Equilibrium constant. You constant hot temperature. The temperature is I have mentioned any temperature. I have not mentioned KT is out. KT is known. And then what is that? Write nicely. This is very important. What you will write this KT is what, right? What is this? Tell me. Gas activities. I'm not replaced. I'm writing first. Always activity, beginning activity. Activity H2O, activity CO, activity H2 cubed, and most importantly, what you write here? Equilibrium. Beginners don't avoid it. What is activity? Right. Activity is what? Gases. Is your activity. Activity is very valuable. But what for simplification? What I will do? I'll use this activity of gas is what? Partial pressure. Partial pressure is handy. Okay, I see this. You know the partial pressure. Yes, 1:3 and total pressure. So what is the partial contribution? So partial pressure finally. So you have to handle the activity. Activity is basically here. Equilibrium constant expression, activity is there. Then what is the activity? If it is pure, solid pure, liquid pure, 1. For gas, partial pressure. So it is all gases I have already mentioned here. So it is what, sir? Right? Can I do this? You don't mind, I hope. Activity becomes partial pressure. Achha, Nirjor, since you actually fumbled a little bit, activity is partial pressure. But partial pressure is atmosphere. So activity will be atmosphere. Denominator is there. There is a denominator. And the activity is Pi by 1. Pi, the pressure of the gas by standard state pressure, which is 1 atmosphere. So atmosphere cancel. Activity has no unit. Never it can. By definition, it cannot have any unit. And it does not. So partial pressure by 1 and 1 does not. So Pi itself. See that this is the activity. Or quickly, partial pressure. I want to go to this which way? So partial pressure is, tell me, mole fraction. Write once more, mole fraction. Let me write. Keep on writing. Quickly, go systematically. X CO, X hydrogen cubed. Mind. Then you still further, okay? Further, equilibrium. Always tag equilibrium. If I forget, you don't forget. X is what? NCH4. What is XCH4? Tell me. N total times NH2O. Please write, complete this line. NCO, good boy. N total NH2O by N total. Oh, I have made a mistake. So you have not noted this. Partial pressure is mole fraction. No, it's very good. I'm not yet. What have you written? Oh, no.
H2. Below your
H2. That is fine. That is another mistake I made. What is this?
should be total pressure.
Total pressure. Okay, so right. Partial pressure is mole pressure. Let me write. Can I write here? So I'm very sorry. Right here. Pressure. Pressure. I'm very sorry. This is clumsy. It is mole fraction time. Partial mole fraction total pressure. This is XCO P. This is also likewise XH2 P whole cube. It's okay though? You have actually it's okay though. Total pressure. So I'm writing how many P is coming? P square by P4. So by 1 by P square. Will you mind? This is out. P is 1 atmosphere later on, but don't worry. So you write this nicely. This I'm giving you this thing. You go stop. Remove this. Is it any needed here at all? This one you don't need. You don't need anything on this. Okay, this problem is given here. Huh? So you please here write KT nicely star nicely now. Since we have enough space, I am very comfortable now. N is let me with me. N is CH4 sir times NH2O sir. Okay, over NCO NH2O cubed, and what remains below P square and up NT square. So NT, actually write this. You please check this first of all. Then I can proceed. This always happens. You see, NT by P. See, NT denominator and P numerator. NT denominator. Oh, here actually, yeah. Remember, yeah. You remember. Don't forget this part. And make a barrier here. Make a barrier here. Now next problem. It's one by P square showing and NT here from NTs. So always this happens. NT and P in the one numerator and another denominator, and remember this happens always. Okay. So P is how much incidentally? Okay. So NCH4 now. What I missed here? Tell me. It will be on. Very easy. Then it will be easy for you. Oh, no, not yet. P is how much? P is how much? Tell me. One answer. So NH2. So you write this. NCH4 is what? Please alpha. At equilibrium, go along alpha. Only don't look at this. Initial line has no significance. Equilibrium. Refer to equilibrium. Alpha into alpha. And then n minus into 3n minus whole cubed. Good boy. Then n total square. What is n total? 4n minus 2 alpha. Remember this is all n total for gas molecules. These are all gases, so no problem. But later on I will show you. You have to be careful. So don't involve solid because partial pressure is mole fraction times total pressure. All this apply for gases, not for solids. Sometimes gas solid reaction you come across. I'll take example. Then you should not be okay. You should not be confused. Okay, good boy. So next, or this is KT. Okay. Now you do these things. Okay. What is this? 4n minus 2. So what is this? Alpha square. 4n minus 2 alpha square, it is 27 n minus alpha to the 4. Perhaps correct. This is K, or make a square root or root KT. Tell me, alpha into quickly 4n minus 2 alpha. This is pretty easy. Root 27 n minus alpha whole square. Correct. Some room. Okay, this is CO gas. I should not disturb this reaction. If reaction is removed, then you will be deep trouble. CH4 gas. Please. Is what? Or you dividing by or writing or root. Is what I'm writing here. Alpha by n. Follow me first. Follow me, then you understand. 2 alpha by n root 27 1 minus alpha by n whole square. What I have done? Dividing numerator and denominator. Good boy. And denominator by n square. No? Then you have got this n square. Alpha by n. Distribute this. Okay. And let this side. Let alpha by n is m. Then what it is? Root KT is m into 4 minus 2m by root 27 1 minus m square. Happy? Happy. You are very happy. M. Shorten it. Alpha by n. Why alpha by n? Call it m. Another one. M. It's okay. 1 m square. So this is a quadratic equation in M. This is a quadratic equation in M. So you can get solve out M. M is found. M is known. Any quadratic equation you can solve. M is known. M means what? So that is what is M? Alpha by N is found. Okay. Now answer the questions. Your question is what? What is the equilibrium composition? Okay. Percentage. So shall I think this part I am not interested. I can do from this. Okay. What is the first take up? What is now equilibrium composition? Final answers. Equilibrium composition means if I ask you any time equilibrium composition, what is this? Mole fraction or percent 100 times. If you give partial pressure and total pressure, from which you get mole fraction? Partial pressure by total pressure. So many ways. So mole fraction, equilibrium composition, CH4. XCH4 is what? Tell me. Remember what is XCH4? Alpha by, tell me. XCH4 is alpha by total 4n minus 2n. Again divided by n, numerator denominator. What is this? Alpha by n, 4 minus 2 alpha by n. You know alpha by n, so it is alpha by n is known. So is XH2 is similarly same because the same number of moles, everything same, the same respect. Similarly, I will not do this. Similarly, XCO is what? Tell me. XCO is n minus alpha by equilibrium composition, equilibrium 4n minus 2 alpha. Then what will do? Yes. Okay, Sukalna, what will do? How get this?
1 by n.
Divided by n. Numerator 1 minus alpha by n. 1 minus 4 minus. Oh, you understand this. So similarly, X hydrogen, you do yourself. Okay. So problem 3, problem 4. Move on. This. Any question? Easy, very easy problem. So that's why I didn't discuss much. Okay. Problem 4. This is very interesting problem coming to us. Okay. Consider the. I'm sorry. Okay. This is the. Consider the. Calculate. Let us start. Calculate the vacuum required to dissociate. I am to cause decomposition of solid. Let us use their language to cause the decomposition of MgO solid into magnesium vapor, magnesium and oxygen gas at 1873 Kelvin. This is the okay. Okay. So I remove this. All these things are over. Start. Quickly. What is the reaction? We will write solution. Achha, here also I tell you what. Achha, I will test. The reaction under study. This you must write. Study. Tell me. MgO solid is Mg vapor, half O2 gas. Mg solid difficult, Mg vapor. Mg vapor. What is delta G0 is A plus Bt is given to. I'll give this data this time. Is given. I'll give you data at the end. Okay. But I give you a sketch. What is this? Is action. Reaction under study. Using the data. Delta G0 data. It can be seen. It is seen. Delta G0 is large positive value. Large positive, exact value I will give you. Large positive, any value is given. I have written here large positive. I'll give this large positive. Then what you will write? Then what comment you will make? What comment? The under, so this implies under standard state reaction will not be possible. Delta under standard state, what is standard state reaction? Reactants, products, all are standard state. Then delta G is delta G0. Delta G0 positive means delta G is large positive as well. So this implies under standard state condition the reaction won't occur. Means what? Condition what? Right? This means what? That is condition that is PMG is 1 nanosphere each standard state, not only one. PO2 1 nanosphere and MgO solid is dissociating this pure standard. Yeah. Under standard state condition, reaction is not feasible. Not only this, not only that, even when the each PMG plus PO2 together is 1 nanosphere. Together means open to atmosphere. With gas coming, open to atmosphere, total 1 nanosphere, the reaction is still, it can be shown. It can be shown. It can be shown. This I am shown delta G is positive. That is reaction not possible. What is this? I am giving the picture. What is this next one? This one follow. I have taken reactor. Again crucible, MgO solid. There is a temperature T 1873 Kelvin means 1600 degree centigrade. 1873 Kelvin. If you have this, let's say follow. Very interesting. What is open to atmosphere? Open to, as you call it, open to atmosphere. What is the total pressure? 1. So Mg vapor and oxygen coming under 1 atmosphere. Delta G is positive. Is it possible? Open to atmosphere. So that means under this condition, reaction not open atmosphere. Total pressure is 1. Means who are constituting the 1 atmosphere? Now the polar gas. Gas share the total pressure. So Mg and oxygen. So under this condition, reaction not possible. Slowly, this problem follow. A moment ago, again see, I gave you a lesson, na? Valuable lesson. What is it? If a reaction is impossible, how to make it possible? Thermodynamics gives you. Thermodynamics says it is not possible. Then you say, oh, you can do this. What you will do now, Sukolan? Then what you will do? Decrease the G of product. G of product means activity.
Yes, activity.
How to do this? Practically, how what? Yeah, I will produce them 1 nanosphere total. Oh, sir, no. How to decrease these are the gases. Gases activity is governed by their partial pressure. So partial pressure. So I should reduce this pressure, sir. 1 nanosphere. No, never. Vacuum, sir. This calls for vacuum. And actually, there is actual section called vacuum metallurgy. This calls for not possible. This calls for vacuum. Vacuum required. Topic is vacuum required. Unless this will not come down. So to solve this problem, this is a little bit lengthy though. But can I remove this? This part is okay over. So what is the value of this vacuum? This is the problem. What is the pressure? What pressure? Vacuum means what is the pressure? This pressure will be less than 1. That is the answer. That is the vacuum. That is the pressure. So find out. So what is the total pressure? So how to solve this problem? I tell you, this problem can be solved. Consider this. Before solving this problem, what is this called? Okay, continuous reactor problem. I write this continuous reactor problem. Acha, maybe let us try this. What happened? Oh, this was actually flat. Before solving this continuous reactor problem, no, this is not. They almost run out. Let us see. We consider the following closed system problem. We consider the following closed system situation. closed system consideration. Closed system situation. What is this? Follow me, follow me. See, I will give you the answer. See, you have considered this. Hey, MgO solid you have taken. Happy? Then what will happen? Vacuum, zero pressure, full vacuum. That is, P total is 0. Temperature T, 1873 Kelvin. Closed system, okay. Now what will happen? This will, since vacuum, it will react. React to go where? Since closed system, go to equilibrium very easily, sooner or later. How we consider equilibrium? Non-equilibrium. Initial, non-equilibrium. We write this, but our interest is where? To the equilibrium one. A time will come when it will be equilibrium. MgO solid still remains sufficient quantity perhaps. So you have Mg vapor and oxygen gas in the system. Oxygen gas, okay? Sorry. MgO solid. Okay. This is final or equilibrium. Now, temperature. Thermostated. So how to, can we find this value? See how to find this value. To find PMG, in this case PMG and PO2, and hence P total, which is nothing but PMG plus PO2 in this, in the final state, to find in the final equilibrium state. In the equilibrium state. You follow with me. Acha, I am actually, don't mind, I am removing this part. This part. You don't need. This is some explanation. You start, give a start. You follow this. This is equilibrium situation. This reaction is at an equilibrium. I can apply equilibrium constant. So I give this. I will actually give you exact data because I have the exact data, but for the time I am not giving you the data because I am considering the problem in principle. Delta G0 is what? The outline. Delta G0, hot temperature 1873 is found. That gives you equilibrium constant K 1873. That leads to known. It is known, right? Give a tick mark. Known. What is this? Right? Tell me. Equilibrium. Say, see picture. This is one. Another is a mental picture. This. A projector. Oh, I see this equilibrium. This way. Oh, you are in search of equilibrium. Equilibrium entails which species. If anything is there, that is produce pure, just like this part I have said. Okay, okay. Produce pure one I have said. Another is actually. I will tell them quickly. So what is this? So these are the, I write PMG. PO2 power as it should be. Activity of MgO. Write equilibrium as in beginners. I have always insisted. What is this value? You know. See what is this value? 1. Sorry. PMG. Why I have written PMG here? Why I have written again? Nirja, I am asking you same question. Yes, what is? Yes. No. No. What I am asking you actually? Anurag, tell me why I have written PMG? Actually, what it was? Always activity, sir. Safe place. Go to the safe place. Activity. So everyone stops. Activity of gas. PMG one. Miss PMG. That's activity is partial pressure already. Actually, it has been gospel truth. Activity of gases is partial pressure without any. And this is also okay. It's okay though. Activity of. Shall I write activity? Shall I write here? Okay, right. I can write then if you ask me. So I'm writing for you. Activity. And I am writing here for you. Activity. What is the next line? Tell me. PMG, PO2, power half. That's by 1. Don't have to. Equilibrium. This is one equation. This is known. So equation 1. What is second equation? I am writing this. You follow. That's why I have actually taken up this situation. I am writing second one from PMG is 2PO2. I'm writing from stoichiometry. From stoichiometry. Do you believe this? Call it equation 2. Call it equation 1. Call it equation 2. Is okay? Why you believe this? Of course, sir, zero means now no one was there. No oxygen was there typically. AIP, air was there. So when 1 mole of Mg is produced, how mole of oxygen is produced in a constant volume reactor? Closed system, constant volume reactor. So 1 is to half. When 1 mole, half mole. When 0.1 mole, 0.05 mole. When 100 mole, 50 mole. So half as much. So that's why if moles are this, 1 is to half, then partial pressure also in a given volume and given temperature system. Ideal gas, PVC and RT. If partial pressure will follow the moles because volume is fixed, temperature is fixed. Constant volume reactor I consider. Constant volume, constant temperature. Okay. So this is follow. Since right, or shall I write? Since NMG is 2NO2. Anytime, since NMG is 2. Why this? If some oxygen was there, I tell you, warn you, if some oxygen was there initially, say AR, full vacuum is not established, was not established, then you can you write this? Some oxygen already there. What are produced in stoichiometry, but you already actually had some initial oxygen, okay? So that will have actually a greater proportion. Follow this. So very nice. So 2 unknown, 2 is solve for solve 1 and 2. Sorry, solve 1 and 2 for what? For what? For PMG and PO2 and 2. Then what is the P total pressure? P total is what? Tell me. P total. What is the P total here? Or kya? Or who else is here? Or solid? Who else is here? PMG is will MG will exert pressure? Solid. Solid vapor pressures are negligible. Okay. gas are present. PMG plus PO2. You right? These are all equilibrium values. Remember, these are all equilibrium values, and this is equilibrium situation. And answer. This value happens to be, if I can write it, and I have not written it, but I will give you the value exactly. I'm giving the value because I will give the whole calculation here. So to have an impact for this, the value will turn out to be 6.39. This actually may interest you. 6.39 times 10. I'll give the full solution. 10 to the minus 7 atmosphere. But follow me. The principle. Okay. Now answer this question. Sir, this is not the problem. Problem is this. Problem is this, sir, not that. What vacuum? So can I sketch? I'm sketching this. So you see what I'm writing it. 1 atmosphere, no. So what is the sketch, sir? This is the device sketch, sir. Yes, sir. Yes. Take, sir, here MgO solid in the powder, etc. And what is this, sir? This is to vacuum pump. And what is the pressure? This is the question. Vacuum required. This you will answer. But for the time, this is the temperature is what? 1873 K. Vacuum. Vacuum you will apply. This you have got this value. So this value you will apply here. I tell you what. You will apply what value? You know. You will apply. These refers to equilibrium. P total. That will be helpful for you. Equilibrium. This is together equilibrium. This is equilibrium. So do you want equilibrium or disruption of equilibrium? So you might say that this is my answer. No. Good answer will be yes. If this is the, maybe some, I will answer this. So this will be, second will be P total less than. So the delta G is negative and forever negative. Okay, follow this. This is very interesting. Is less than. This is not, this mole is not enough. With this it will stop. I'll show you. It must be less than 6.39 into 10 to the minus 7 and also is your answer, right answer. Okay, this vacuum is required. This is actually turbomolecular vacuum pump, maybe. Rotary, vacuum pump, rotary vacuum pump, and there is actually another is what? Diffusion pump. higher order rotary pump, and then turbomolecular, and the high order vacuum pump is required. To get magnesium, magnesium is very important to metallurgists like me. Follow me. Why, sir? Sir, you might argue here, sir, has not MGO dissociation taking place here? MGO dissociation has not taken place? Yes. But then stopped. Is it? Then stop. But what is our purpose? Metallurgists, I want to convert the MGO fully produce Mg, like iron oxide, full iron. Not actually halfway or part way. Full conversion is needed. So continuously make delta G negative. This is that. So this you don't want this. So what is happening? This refers to K. I'm explaining. This is refers to Q less than K, and delta G always negative. But this is actually looks actually difficult to follow. But I tell you, one thing you tell me, follow with me. Example I'm taking. Example. Then I will take up actually the real data. The problem is over. This answer I will get to. But I'm discussing something. Actually, consider this puzzle, numerical, arithmetical puzzle. See what I'm saying when it happens. Suppose we consider 8 and 2. Consider example, analogy. Consider two numbers. Consider two numbers, simple numbers 8 and 2. Follow me. So 8 into 2 is how much? 16. You don't have doubt. And 8 plus 2 is what? 10. Now, with a value less than 10, with a value, with a sum less than 10, sum of two numbers, with the sum of two numbers being less than 10, of two numbers like this, type quickly, being less than 10, can you have the product get a less than equal to 16 or above? Sum down, then product can never be 16 or even above or even 16. Impossible. This you can say quickly practical. 10, sum less than 10, like say what? 9. Say EG 9, say EG 9 or 8 or 9 I'm taking. Closest. So 7, what is the possibility? 7 plus 2, then 7 plus, no, I'm very sorry, 8 plus 1. Oh, for quick, the analogy is very interesting. 8 plus 1, possible. 7 plus, 6 plus 3, 5 plus 4, and there is no more, because it is 4 plus 5 is same. So what is the corresponding product? Product is, good boy, product is 8 good times 1, so 8, here 14, 18, is gradually increasing. Here what happens? I made a mistake here. Sum 8 plus 2 into 16. What are the what I'm doing here? 7 plus 7, 8 plus 1, 7 plus 2, 14. Then what? Hey, what are you doing?
Sir, we have multiplied.
No, wait. 10 is the product sum, with the sum less than 10, like 9. How can I achieve 9? I made a mistake. Maybe I have to check this. Sum 9. So the product, then I'll do the product, but product will be, if the sum is less than 10, if sum is less than 10 means 9, the product will be, so this I have to check, this particular, I will check on this, but the answer is okay. Now what I am saying here, I will check back on this, okay. Well, this analogy should have worked actually. 8 into 2 is 16, 8 plus 2. If any sum less than 10,